Zeal Education Society, redefining excellence.
Good morning to everyone. Myself, Dr. Mahadev Unde, Professor in Electrical Engineering Department, Zeal College of Engineering and Research, Pune. In this video lecture, we are going to learn what is hunting of the synchronous motor and what are its remedial measures. Now, when the synchronous motor is loaded, the rotor falls back and the angle is generated between stator polar axis and rotor polar axis, and it is known as load angle or a torque angle or a power angle. But if the load on the synchronous motor is suddenly increased, rotor falls back and oscillates about its new axis for some time before coming to rest. But because of moment of inertia of the rotor, it takes some time to settle to its new position. These oscillations of the rotor is known as hunting, or it is also known as swinging of the rotor. The rotor surge, in other words, we can say rotor surge or a hunt a new equilibrium position, and hence the name hunting. Now, similar type of phenomena may observe when the load on the synchronous motor is suddenly removed. Motor will accelerate and tries to find out new equilibrium position along the new axis. Now see what happens because of this. So if we plot a graph of load angle delta on y-axis and time on x-axis, the graph will look like this. And so on y-axis there is angle delta and x-axis time. So it swings like this and settles to its equilibrium position after some time. But if this swing is maximum, the swing means the rotor angle, this delta increases, becomes maximum and again decreases, then the system will remain stable as per the stability systems or as per theory of the stability. Now here, if these oscillations are more and if these oscillations match with the natural oscillations of the synchronous machine, the resonance may occur. Okay? And sometimes these oscillations exceed to a certain value and the synchronous motor may fall out of synchronism. So what is the remedial measure on it? So the remedial measure is to use the damper winding. Now what is the damper winding? The heavy aluminum or copper bars are placed in its pole shoes. And these pole shoes of the rotor circuit, and they are short circuited by the end rings. So these are the heavy aluminum or copper bars placed in the pole shoes, and they are short circuited on both sides by end rings. So the synchronous motor rotor behaves like a squirrel cage rotor. So what happens when the rotor starts oscillating? There will be a relative speed between the damper winding conductors and synchronously rotating rotor field. Then according to Faraday's laws of electromagnetic induction, EMF gets generated in the damper winding, and as the circuit is closed one, the damper winding or damper bars circulate the current according to the Lenz's law. That is, it opposes the very cause producing it. In this case, the cause of production of the EMF is the relative motion between the damper winding and the rotating magnetic field, and thus this current damps the oscillations of the rotor. Okay, so what are the effects of the hunting on synchronous motor? Now see, it may lead to loss of synchronism, just now I have stated. Then produces the mechanical stresses on the rotor shaft, increases the machine losses and causes the temperature rise, causes greater surge on current and power flow. It increases the possibility of natural resonance. When these oscillations of the swinging rotor match with the natural frequency of the oscillations of the machine, there are chances of the resonance. Okay. Now resonance, this hunting of the machine is over. Now let us see the synchronous induction motor. What is this synchronous induction motor? It is the combination of synchronous motor and slip ring induction motor. It has high starting torque. It has high starting torque and a power factor, but draws less armature current and has constant speed and cheaper than the synchronous motor. Okay. So, if you observe carefully this diagram, just a minute. Okay. This one is the stator of the induction motor, that is a star connected sync. Okay. It may be a delta connected, the armature winding placed on the stator. And this one is the rotor. Rotor is wound, means regular three-phase distributed winding, short pitch distributed winding is placed in the rotor slots. And it is always star connected in order to accommodate the external resistance in the rotor circuit. So this is the star connected rheostat. On the right hand side, it is a variable rheostat. And on the left hand side, a DC excitation system is shown. And this one is triple pole double throw switch. These are the slip rings which are insulated from the shaft, and brushes are resting on the slip rings. Okay. So with the help of these slip rings and brushes, it is possible to add the external resistance in the rotor circuit during starting of the motor in order to improve the starting torque, power factor, and when whole resistance is cut off, motor run near to synchronous speed. Then feed the DC excitation to the same winding. Observe carefully here. The positive is supplied to the say R phase, this phase the current is flowing, and remaining two phases magnitude of current is half. Okay. So in this way, the combination of such a induction, slip ring induction motor with excitation system is also known as synchronous induction motor, and it has many advantages over the synchronous motor. Okay, it runs at a synchronous speed, whatever may be the load on it. It has a higher starting torque and higher power factor as compared to synchronous motor with less armature current. Okay. So now let us see the comparison of three-phase synchronous motor with three-phase induction motor. The first point is synchronous motor. It is not self-starting, inherently not self-starting, whereas three-phase induction motor is self-starting. The second point, it is a doubly fed three-phase motor, means three-phase supply is fed to armature winding as well DC source is fed to the field winding. In this way, it is a doubly fed motor, whereas three-phase induction motor is a singly fed, and in which three-phase AC supply is fed to the armature winding only, and there is no DC supply is required. The next point, third point is, synchronous motor works over a wide range of power factor ranging from lagging unity to leading power factor, whereas induction motor works on only lagging power factor and its power factor decreases to a small value on no load. On no load, power factor is generally less than 0.5. Okay. Then the point number 4. It is a constant speed machine. It runs either at a synchronous speed or not at all. Whereas for the three-phase induction motor, its speed falls when the load on the motor increases. Okay. Then the next point, the synchronizing torque. TSY, synchronizing torque is directly proportional to the applied voltage and slightly affect the torque. Whereas in case of three-phase induction motor, torque is directly proportional to square of applied voltage. Now the next point, the synchronous motor, it's costly and complicated construction, whereas the three-phase induction motor is very simple and robust and cheaper construction. Now the three-phase synchronous motor can run at a very low speed using the converter. It cannot be run at a very low speed. Damper winding is provided in a pole shoes, whereas three-phase induction motor does not require the damper winding. Used in rubber mills, paper mills, blowers, compressor, power factor enhancer are also used as a cheap source of reactive power control. Whereas three-phase induction motor is used. Three-phase induction motor is used for driving the machine tools like lathe machine, milling, drilling machine, etc. Water pumps, woodworking machines, fans, pumps, blowers, etc. Okay. Then see the applications of the synchronous motor. First, already we have discussed so many. So power factor correction. Then it is used for constant speed drive load. So constant speed drive. Then the reactive power compensation. It is a very flexible source of reactive power compensation. During the lagging power factor, it can absorb the reactive power, whereas during leading power factor, overcompensation, it injects the reactive power in the system. Then can also be used as a constant speed drive. Speed above 600 RPM can be used as a centrifugal pump, reciprocating compressors, blowers, rubbers and paper mills. Below 600 RPM can be used as a vacuum pumps, centrifugal pumps and rotary kiln, rolling mills and cheapers. So we will stop here. Thank you very much.